Okay, just a quick lecture to talk about upper and lower real limits and the use of interpolation. So for interpolation, we have to know how to use upper and lower real limits, so we'll start with that. Whenever you measure something, you always measure to some level of precision, right? And however precise you are, you can't go more precise than the tool you're using, right? If you're using a ruler that only is marked on the inches space, you can measure to the nearest inch. If it's marked to the quarter inch, you can mark to the nearest quarter inch, so on and so forth. The more precisely you measure things, the further out you can go in terms of precision of measurement. Think about decimals. But for however precise you're measuring, at some point you're making a determination. Okay, is it closer to this value or this value? Think for a minute, if you were to measure a length of something and you had a tape measure, this weird tape measure that only had markings every 1 meter, right? So if you measure something and you use your measuring tape that has markings every 1 meter, and you go, okay, this is it's about 9. I'm going to write down 9 meters long. Okay, well, if you're making that judgment that it's 9, you've got a mark at 9, a mark at 10, a mark at 8. Right? And you've decided, okay, it's closer to 9 than it is to 10, right? Which means that at the most, it's going to be 9.5. If it were greater than 9.5, you would have said, oh, that's a 10. Same thing. You've decided it's closer to 9 than it is to 8. So the least it can be is 8.5. If it were any less than 8.5, you would have said it was 8. So when you're going back and looking at the number and you wrote down a 9, you go, how long was that really? Well, it was somewhere between 8.5 and 9.5. 8.5 being the lower real limit of that measurement, that observation. 9.5 being the upper real limit, right? So we have this measurement and we know that, okay, that's generally at some point an estimate, and the real value is somewhere between here and here. So to figure out the upper and lower real limit, obviously for whole numbers, pretty straightforward. So if we look at this one, we have a measurement of 20. First thing to think about is what's the next highest possible number. So not the next number you have if you have a whole bunch of data points, just what's the next possible number, measuring this specifically. At this point you're measuring to the ones place, right? So the next highest possible number is 21. Okay. So the upper real limit is halfway between what you measured and the next possible one. So halfway between 20 and 21 is 20.5. Okay. For the lower real limit, we think, okay, what's the next lowest possible number? Okay, below 20, we drop into 19. So the lower real limit is halfway between, which is 19.5. Now, imagine we measured more precisely. We measured all the way to the 10th place, and our measurement is 20.4. Okay, now the next highest possible number isn't 21, right? Because we're measuring more precisely. The next highest possible number at this level of precision is 20.5. So halfway between 20.4 and 20.5 is 20.45. Oops. Same thing with the next lowest possible number. Below 20.4 is 20.3. So the lower real limit is halfway between 20.35. And we measured even more precisely, all the way down to the hundredths place, 20.42. All right, well, the next highest number isn't 20.5, it's not 21, it's 20.43. So halfway between 20.425. Excel for always rounding for me. Same thing for going lower. Below 20.42 is 20.41. Halfway between is 20.415. Pretty straightforward, right? So if you have a number, however precisely you're measuring, think about what's the next possible measurement at that level of precision. Upper real limit halfway between. Same thing for lower, just going below. We can do the same thing with class intervals. If we have like a group frequency distribution table, those intervals have upper and lower real limits. So if we have measurements that are measured just to the level of specificity of the ones place, but we're kind of grouping them so it's even less specific, okay, there's a data point and it's somewhere between 5 and 9. Well, if it's somewhere between 5 and 9, really, in terms of real limits, well, you're saying at most it's 9? Well, no, it could be a little higher. We have to think about the upper real limit of that 9. So it's the next highest possible number. And again, you don't go to the next highest possible number is 10 to 14. The next highest possible number is 10. So the upper real limit of that interval is 9.5. next lowest possible number. Again, you don't go from 9 down to 8. You go from the bottom of the interval to the next number, which would be 4, right, at this level of precision. So the lower real limit of the interval being 4.5. So if there's a data point in that interval, according to the upper and lower real limits, the real value of the data point is somewhere between 4.5 and 9.5, which should check out if you're, well, how large is that interval? Well, take the upper real limit minus the lower real limit. 9.5 minus 4.5 is 5. Yep, that checks out. That interval is the size of 5 data points, because you have 5, 6, 7, 8, and 9. Those 5 different data points can go in that interval. If we have large numbers still measured to the same level of precision, it's not really that different. 200 to 249. Next highest is 250. Next lowest is 199. So upper limit is 249.5. Lower real limit 199.5. Right? And it'd be the same thing if we have class intervals that are measured to the tenths, to the hundredths. We do the same thing we did before. You just think, what's the next possible number at that level of precision, and then go halfway between. Okay, so that's upper and lower real limits, which we need to know for interpolation. There's two things we can do with interpolation if we have a frequency distribution table or a group frequency distribution table where we have frequencies and cumulative percentages. One thing we can do is we can find the percentile rank for a known score. Right? And an important thing to note before we get started with kind of all these formulas is everywhere you see a score, so let's say this 28, you think, okay, well, 28, cumulative percentile is 78.57, so the score at the 78.57th percentile is 28, right? Close, but not quite, because 28 isn't really the top of this interval. This interval has upper and lower real limits. It goes from 28.5 down to 27.5. So what score is at the 78.57th percentile? Well, 28.5. Right? Even if that's not an actual observation, mathematically, in terms of interpolation, that's how it works. Right? So what score is at the 92nd.86th percentile? That would be the upper limit of this one, 29.5. Okay. So for all the upper real limits of intervals, we can look at the cumulative percentage and get its rank. For anything else, not so clear. So we'll look at an example for a score of 27, right? And I just said 27, wouldn't be at the 64.29th percentile. That's where 27.5 is. So we know 27 is somewhere less than that, and it's somewhere greater than the 42nd.86th percentile, because that's where 26.5 is. 27 is somewhere between those two. Well, where exactly is it? Well, we can figure it out by figuring out how big that interval is and how many scores are in here and kind of how far it is in that category. So the way I do it, kind of broke it down into a little formula. We start off by calculating the width of the score interval where the score that you're talking about is. So this is the interval that it's in is just this 27, which goes from, again, the upper real limit of that is 27.5. The lower real limit is 26.5. So the width is equal to 27.5 minus 26.5. You probably don't need to do the math on that. In fact, it is 1, right? That's an interval width of 1 when it's not a group frequency distribution table. Okay. And then where is the score in that interval? That's the position, right? So the upper real limit of the interval we said was 27.5. The score we're looking at is 27. We just calculated that the width was 1. And so the P is equal to, the parentheses here, the upper real limit, 27.5 minus 27. Okay. So the upper real limit of the interval it's in minus the score you're looking at, whatever that result is, divide by how wide the interval is. This one's pretty easy. So it's halfway up. Okay, right, because again, that interval goes from 26.5 to 27.5. 27 is halfway up that interval. Okay, so if it's halfway up that interval, how big now is the percentile interval we're looking at? So we look at the width of this percentile interval is going to be equal to the cumulative frequency percentage of the interval containing the score minus the cumulative frequency percentage of the next lowest score, next lowest interval. So the one containing it, 27, is here with this cumulative frequency of 64.29. That's where the score we're looking at is. It's somewhere in there. The next lowest is this 42.86. So the width of that interval is just equal to the first one minus the second one, right? 64 minus 42. All right, it's 21.43 percentage points. So the answer would be what we the cumulative frequency percentage where the score is minus p times the width of the interval. So the cumulative frequency where the score is, we said already, was 64.929, right? P we calculated was 0.5. The W percentage, the width of that interval, we said was 21.43. So then the answer is equal to the cumulative frequency percentage with the score minus the P times, little asterisk, W percentage equals, okay. So a score of 27 in this data set is at the 53rd.58th percentile. Right? So a little bit above the median. We can also, so for that, we're looking at, given the score, what's its rank? We can also do the reverse. For some known rank, what's the score? So what score is at the 75th percentile? So this is very similar. It's kind of doing things a little reverse. You start off with, okay, well, what's the cumulative frequency percentage with the rank you're looking at? Okay, so where is the 75th percentile? What score is that? What category is that going to be in? Well, it can't be here. This is at the 64.29th. 75th percentile is above that, so it's not in. It's not here. I mean, it's got to be somewhere in the next one above it, right? Because the 78 includes 75. So that is 78.57. It's in there somewhere. And then you have the cumulative frequency of the next lowest. We always drop down to the next one. It's that 64.29. Okay. So the width of the percentage interval is equal to, again, 1 minus the other. 78 minus 64. All right, so just like we did before, we did the width of the interval, we did it with scores, now we're doing it with percentages. Then we find the position of the score, now we're finding the position of the rank. So again, the cumulative frequency percentage, where it's at, which we said it's somewhere in that 78.57 interval. We need to know the rank we're looking for, which we said was 75. The width of the percentage interval we calculated was 14.28. So then we just do the math for P, which is equal to, again, I'll do my parentheses, the first one, so the cumulative frequency where it's at, minus what we're looking for, in parentheses, divided by the width of that interval. So how far up or down is it? Okay, it's at 0.25. Cool. Then I'm going to find the width of the score interval. For the, again, not the percentage, but the score itself. And again, we're looking in this interval here, right? Because it's above 64, but can't be any higher than 78. So it's in this 28 interval. Upper real limit of that is 28.5. Lower real limit is 27.5. And what do you know? The width of the score interval is still just 1. So the answer for the score. So we have the upper real limit of the interval. So the interval it's in, it's somewhere in that 28 category, which the upper limit of that is 28.5. We calculated the position to be about a quarter of the way up. The width of that interval is 1. So then the answer is just equal to the upper real limit minus the position times the width. So 28.25 is at the 75th percentile. Okay. Let's do one more of these real quick. I'm going to change this to the 50th percentile, right? Because that's what you would do if you had to find a median. So the 50th percentile, okay, well, it's got to be above here. It's above 42. Can't be any higher than this. So it's somewhere in this 27 category. So for the 27 category, the cumulative frequency that it's in is 64.29. The next lowest is 42.86. Still have my subtraction in there. The one it's at auto-populated for me to 64.29. The rank we're now looking for is 50th. The W auto-populated from what we calculated before. So this position, okay, within that 27 grouping, it's up about 2/3 of the way, 0.667. Right, upper real limit, not really going to change anything, but to be accurate, we're going from 27.5 to 26.5. Still 1. Upper real limit auto-populated from what I had before. P grabbed it from up there as well. W grabbed it. The answer is 26.83. So 50% of the scores are below 26.3 and 50% of the scores are above 26.83. All right, now I'll show you one more thing. You can do the same exact thing with a grouped frequency distribution. So for this one, let's look at find the rank for a known score. If the score equals, let's say 54. Doesn't matter which one you do. All right, so 54 is somewhere in here. Right, this is the interval we're looking at. So what's the upper real limit of that interval? Okay, it's 50 to 59, so the upper real limit is 59.5. Lower real limit, you go down to 50. Next one is 49, so the lower limit is 49.5. So the width is equal to first one minus second one. We just said the upper real limit of the interval was 59.5. The score we're looking for is 54. The width we just calculated was 10. So P is equal to, parentheses, upper real limit minus the score. So how far away it is divided by how big the interval is. Oops. So divided by, don't forget your backslash, divided by how big it is. And that gives me its position. Okay, that's part of halfway up that interval. So the cumulative frequency that has it, as it's highlighted there, you can see it's 70.59. The next lowest is 47.06. So the width in terms of percentages is first one minus the second one, 23.53. We just said that the cumulative frequency that has the score, it's somewhere in that one with 70.59. P we calculated as 0.55. The width of the percentage we calculated as 23.53. So the answer is equal to score minus P times W percentage. Okay, 57.648 percentile. So 54 is somewhere above the median. Okay. So again, let's say find score for a known rank. Let's again look for the median. So the rank is going to be the 50th percentile that we're looking for. So unhighlight this and we think, okay, where is that median at? Okay, well, 12, 12, about 30, 47. Okay, so it's somewhere above here. Okay, can't be above here. So again, look, we're looking in the same interval we were looking in before. That median is somewhere between 49.5 and 59.5, right? Which, with again, what score is at the 70.59th percentile? Well, the upper real limit of this interval. So the score of 59.5 is at this rank, 70.59. So the score that's below that but above this one is going to be somewhere between 49.5 and 59.5. Okay, so the upper limit and lower limit stays the same because it's the same one we're looking at. Oops, sorry, down here. The cumulative frequency where we're looking at again is 70.59. The next lowest is 47.06. So W is simply equal to first one minus second one. We just said that the one that has the rank we're looking for is this 70.59. The rank we're looking for is 50. The W we calculated is 23.53. So P is equal to, parentheses, first thing minus the second thing, close parentheses, divided by the third thing. Okay, so it's fairly high up in that interval, right? So it's going to be closer to 59 than it is to 50 probably, right? That's weird. Upper real limit of the interval is 59.5. Lower real limit is 49.5. So the width is 10. So the upper real limit is that. P we calculated at 0.875. W, the width of the interval, we calculate as 10. So the answer is simply upper limit minus P times W. So the median is at 50.7495. Oh, sorry, yeah. I said earlier, but it's 0.87. It's 0.87 down from the top, not up from the bottom. So yeah, that makes sense. It is closer to 50 than it is 59. Okay, so that is a fairly quick review of upper and lower limits and interpolation. Hope it helps.